Let's look into the questions 13 to 16, which comes under the end of the chapter questions under the use of coordinates. Number 13, the midpoint of the sides of the length ABC are the points D, E, F. Given that the coordinates of D, E and F are 5, 1, 6, 5 and 0, 1 respectively, find the coordinates of A, B and C. A, B and C are the vertices of the given triangle, and D is the midpoint of AB, E is the midpoint of AC, and B is the and F is the midpoint of BC. The values of only the midpoints are given, and the values of or the coordinates A, B and C we need to find out. So let's consider A, B and C, we do not know the value. So just let's assume A to be equal to x1, y1, B to be equal to x2, y2 and C to be equal to x3, y3. Using the midpoint formula, midpoint D is equal to x1 plus x3. What are x1 and x3? They are the x coordinates of A and B by 2 divided by y1 plus y3 by 2. So the value of D is already given to be 5, 1. Similarly, we just give the values of midpoint E to be equal to. Where does E lie? E is a midpoint of AC. What are the coordinates of A and C? A is x1, y1 and C is we have assumed to be x3, y3. So midpoint E is equal to x1 plus x3 by 2 and y1 plus y3 by 2. The value of E is already given to be equal to 6, 5. Now let's move on to midpoint F. What is F? It is a midpoint of BC. What are the coordinates of B and C? They are x2, y2 and x3, y3 respectively. So according to the midpoint formula, we just replace the value of F to be equal to x2 plus x3 by 2, y2 plus y3 by 2, and the value of F is already given in the question to be equal to 0, 3. So we are just equating the x coordinates with the values and the y coordinates with the corresponding values of D, E and F. So we get x1 plus x2 by 2 is equal to 5. y1 plus y2 by 2 is equal to 1. Assume this to be equation 1. From the midpoint D, we get x1 plus x3 by 2 is equal to 5 and y1 plus y3 by 2 is equal to 5. Now moving on to the midpoint E, it is x2 plus x3 by 2 is equal to 0, y2 plus y3 by 2 is equal to 3. We assume this to be equation number 3. Now we are simplifying equation 1, 2 and 3. Just making it like linear equations, x1 plus x2 is equal to 10 and y1 plus y2 is equal to 2. The equations 1, 2 and 3 we have just simplified. Now we need to minus equation 1 minus equation 2. So we have x1 in both the equations, so it just get cancelled out and we get x2 minus x3 is equal to minus 2. y2 minus y3 is equal to minus 8. Assume this to be equation number 4. Adding equations 3 and 4, we have x2 plus x3 is equal to 0 in equation 3. We have x2 minus x3 is equal to minus 2 in equation 4. So adding these two, what do we get? We get 2x2 is equal to minus 2 and 2y2 is equal to minus 2. Simplifying, we get the values of x2 to be equal to minus 1 and y2 to be equal to minus 1. Now what is x2 and y2? They are the x and the y coordinates of the point or the vertex B of the triangle ABC. Now, what values do we have? We have the values of x2, y2. So, based on this value we have derived, we can find out the other values of x1, y1 and x3, y3. So, we're just replacing the value of x2, y2 in equation 1. What is equation 1? It is x1 plus x2 is equal to 10, y1 plus y2 is equal to 2. Just replace the values of x2 and y2 in this equation. We get x1 to be equal to 11 and y1 to be equal to 3, as we can very well see from the derivation. Now we have got the values of x1, y1, which is the value of the coordinate of the point A. We have the values of x2, y2, which is the values of the coordinates B. Similarly, we can find out the values of x3, y3. How do we go about? We just replace the value of x2, y2 in equation 2 and we get the values of x3 and y3. So, x1, y1, x2, y2, x3, y3, the values we have derived, they are nothing but the values of the x and y coordinates of A, B and C. So, we get the mentioned values. A city has two main roads which cross each other at the center of the city. Let us assume the center of the city to be equal to the origin. So, this is the center of the city. So, it has basically two main roads. One is this main road and the other is this main road. So, the first road is along the east-west direction. In the graph, it is depicted along the from left to right, and the other main road is along the north to south direction. In the graph, it is depicted top to bottom. The next information is that all the other streets of the city run parallel to these roads and are 200 meters apart. So whatever city is there in the street is there in the city, they all are parallel to either the main road along the east-west or the main road along the north-south direction. So each one of this is a street or a road that is running along the city. And one more information they have given is that the distance between one street and the other street is always 200 meters. So how do we put forth in the graph? We make use of this legend as 1 centimeter is equal to 200 meters. So each one of this one is a street or a city or a road, and this one is a road. So the distance between these two is 200 meters. So, what is the first question? Using 1 centimeter is equal to 200 meters, draw a model of the city in your notebook. Represent the roads or the streets by single line. This is the model of the city. So, each one of this is a street or a road in the particular city. Now, we move on to question number 2. There are street intersections in the model. Each street intersection is formed by two streets, one running in the north-south direction and the other in the east-west direction. So, what do they mean by this is a street intersection. If you look into it, this is one road which is running parallel to the east-west and another parallel to the north-south direction. So, this particular intersection, they call it the street intersection. This is formed by two roads, one this road and the other this particular road. Okay, so each street intersection is referred to in the following manner. If the second street running in the north-south direction, the fifth street in the east-west direction meet at some crossing, then we all call the street intersection 2, 5. Let's look into what they mean by the street intersection 2, 5. They say that the second street in the north-south direction, which is the north-south direction, this is the north-south and this is the second street, right? And the fifth street in the east-west, which is the fifth street in the east-west direction, this is the fifth street in the east-west. Where do they intersect? This is the point. So this is the point or the street intersection which is represented by 2, 5. So this is the convention. Using this convention, they are asking us to find out question number A. How many street intersections can be referred to as 4, 3? What is 4? 4 along the north-south and 3 along the east-west. So this is the street intersection. So one street intersection is formed by two streets, one running along the north-south the fourth street running along the north-south, and the third street running along the south east-west. So how many street intersections? The answer is 1. One street intersection. How many street intersections can be referred to as 3, 4? This 3, 4 is this particular point. 3 along the north-south and 4 along the east-west makes this particular street intersection. So how many street intersections it can be formed? It can form only 1 out of 2 streets. 15. A computer graphics display program displays images on a rectangular screen whose coordinate system has the origin at the bottom left corner. So it has the origin where at the bottom left corner. This is the origin they have mentioned. The screen is 800 pixels wide. So we should mark a screen. The dimensions of the given screen are 800 by 600. So you mark 800 along the x-axis and 600 along the y-axis, and this will make the dimensions of the screen. A circular icon of radius 80 pixels is drawn with its center at the point A 100, 150. First, identify or locate the point 100 along the x-axis and 150 along the. So this is the point. So with this point as the center and the radius as 80 pixels, how do you mark 80 pixels in the take out a compass, and this from 0 till this point is 80 pixels wide. So with this measurement as a radius, draw this particular circle, the first circle. Another circular icon of radius 100 pixels. Now we need to take 100 pixels the same way the compass from 0 to 100, making the radius as 100 pixels. You need to draw another circle with the center at B. So what is B? 250, 230. So 250 along the x-axis and 230 along the y-axis. So where the point meets is the point B. With this point B as a center, draw a circle of radius 100. Now what are the questions? Determine whether any part of either circle lies outside the screen. As we have seen earlier, so this is the entire screen. Any of the point is of the circle is lying inside or outside of the screen, they all lie, both the circles lie inside the screen. As we can see, none of the circles lie outside the screen. And the second question is, do they intersect each other? Yes, there is a small portion where they do intersect each other over here. Points A, B, C, D with the given values on the coordinate plane. Is A, B, C, D a square? We just have to plot the points, find out the length of A, B, B, C, C, D and D, A. Find out if all the four are the same. If they are same, then it is a square. But for a rhombus also, all the four sides could be equal. So we need to find the lengths of the diagonals. If the diagonals are equal to each other, then we conclude that the given figure or the figure that is formed is a square. How do we find the length of these segments? Of the length of the sides AB can be found out by making use of the distance formula. So length AB happens to be square root 10 units, which happens to be the same as length BC, same as length CD and same as length DA. Every length of the side, each of the side being equal to square root of 10 units. Now the diagonals CA and BD, how do we take the measurement? By making use of the same formula, we can find the lengths of the diagonals, and they happen to be the same also, which is equal to square root 20 units. Since all the four sides and all the diagonals are equal, then we conclude that ABCD is a square.